Hello everyone. Today we discuss from the class 12 chemistry unit 10 topic haloalkanes and haloarenes. Objective nomenclature of haloalkanes and haloarenes, nature of C halogen bond, and halogen physical and chemical properties, mechanism of substitution reactions, stability of carbocations, D and L configuration, uses and environmental effects of CH2Cl2, dichloromethane, trichloromethane, tetrachloromethane, iodoform, freons, and DDT. So actually, haloalkanes and haloarenes. It's an Alkyl halides and haloalkanes are compounds in which a halogen is attached to an aliphatic carbon. The general formula is Rx. Aromatic halogen compounds are those compounds which contain at least one benzene ring and one halogen atom in a molecule. So alkyl halides, alkali to alkyl group to halogen group of alkyl halides mo. So hote hele haloalkanes. Arene hit aromatic aromatic compound to halogen compound to haloarenes. So classification of haloalkanes and haloarenes and so on. Number 1, on the basis of number of halogen atoms. Number of halogen atoms cut on the monoalkane X Cl or Br F fluorine mo. So cut to on the monohaloalkane X ni mo dihaloalkane X 1 2 3 1 2 3 3 on China trihaloalkane na amasana ahile aliphatic haloalkanes kitya here anina monohaloarene arene China benzene ring to halogen group aki attached komjangina haloarenes kitimo. So only one halogen group monohaloarene, 2 halogen groups dihaloarene, 3 halogen groups trihaloarene. Compounds containing number 2 compounds containing sp3CX bond. X is jangina fluorine, chlorine, bromine, iodine again here. So halogen atom bonded to an alkyl group forms a homologous series represented by CnH twice and plus 1x. They are further classified as primary, secondary, or tertiary according to the nature of carbon to which halogen is attached. Now, example in the primary chloroethane has Cl atom ahile carbon attached more. So this carbon is attached to one carbon has C carbon more. So this is primary primary alkane, primary chloroethane. And in ahile this chlorine is attached to carbon. This carbon. He carbon ahile this carbon pen ahile 2 carbon ni ki attach mo CH3 khat CH3 ni carbon ni to aki attach manina secondary carbon kizia 2 degree 2 atunga degree higa no. So third one, the C chlorine group is attached to carbon. And the carbon ahile 1 2 3 3 carbon groups are attached manina tertiary carbon kisi no. Allylic halides. Allylic is itangina compounds in which the halogen atom is bonded to an sp3 hybridized atom next to an allylic carbon. So this one, allylic carbon. This is C double bond C. This is alkene bonded to C. C carbon hijangina allylic carbon. Yeah, C double bond. The next two this C single bond double bond single bond. Pick halogen to okay bond jangina allylic halide. Next one benzylic halide. The benzene ring to CH2 1 CH2 to a chlorine group or the halogen group of the changona benzylic halides benzyl chloride see mo vinylic halides. So just compounds in which the halogen atom is bonded to an sp3 hybridized carbon sp2 hybridized carbon atom of C double bond C. So you have carbon so we have C has C carbon mo carbon double bond hey carbon double bond pen here halogen to here halogen atom to ki bond mo here ki bond changina vinylic halide same thing ring fused ring this is C happen here the C carbon double bond bonded to X is changina halogen atom aryl halides is changina aromatic compound like benzene directly bonded to halogen atom aryl halides kitimo. Nomenclature alkyl halides are named as halo-substituted hydrocarbons. In haloarenes or aryl halides, the prefixes OMP is ortho metapara are used in common system, but in IUPAC system, the numerals 1, 2, 1, 3, 1, 4 are used. Common system ahile ortho metapara kizangmo male IUPAC system 1, 2 ala 1, 3 ala 1, 4 kizangmo. Masana and name we have CH3 CH2 CH2 Br 3 carbon atoms of propyl so Br bromide mo N propyl bromide IUPAC name hile 1 2 3 more 1 2 3 bromo group pen 1 first carbon atom amala 1 bromo propane kisi second one 1 2 3 this isopropyl chloride common name here male 2 chloro group pen 2 position amma so you write 2 chloropropane aromatic and happen here the benzene ring it's what is benzene plus Br bromo so bromo benzene 1 2 3 1 2 3 then meta common name meta dibromo benzene meta is 1 3 positions in so IUPAC name 1 3 1,3 hyphen dibromobenzene. Yeah. The nature of CX bond. Since halogen atoms are more or less electronegative than carbon, the CH bond is polarized. Carbon atom bears a partial positive charge and the halogen atoms bears a partial negative charge. So, negativity, electronegativity ke badlo carbon to fluorine example in lawang hila C fluorine bromine ma lawang hile halogen group they hile they are the most electronegative compounds fluorine but most electronegative element in the periodic ma so electronegative high manina so difference among more carbon to halogen kala so there is difference in electronegativity changina polarized tamo polarized changina fluorine halogen atom ahile more electronegative than carbon changina they become partially negativity changina delta minus akitoniet mo so since carbon changina less electronegative or more electropositive than halogen changin it becomes partially positive when delta plus no preparation of haloalkanes from alcohols Alcohols can be converted into haloalkanes by the treatment with halogen acids. The reaction in general can be represented as haloalkane bolut ahile alcohol abol mo. Number 1 alcohol to halogen acid halogen acid is H halogen plus hydrogen plus any halogen chlorine bromine iodine. You have alkyl halide. So example ROH plus HCl, you have RCl, ROH to NBR, you gom RBR. Second one, from hydrocarbons by free radical halogenation. Alkanes on treatment with halogens in presence of light or catalyst give a mixture of mono and polysubstituted products. Alkane hile halogen to akitrit sang ina nisan waya ay light waya mo avang waya itrit sang ina catalyst using catalyst a mixture of mono or polysubstituted product halogen pen ki add mo tetrachloro methane upon matan ki add. In case of higher alkanes different isomeric products are obtained. So methane, ethane, propane. Second example of methane, ethane, propane. So Cl2 you get isomeric product 1 chloropropane or 2 chloropropane. Number 3, from alkenes by addition of halogens. Haloalkanes can be prepared from alkenes by addition of halogen acids. In unsymmetrical alkenes, the addition of halogen acid takes place according to Markovnikov's rule. Markovnikov's rule is class 11 akisim mo na. Markovnikov ahile class 11 the rule states that in addition reaction of unsymmetrical alkenes, addition of halogen takes place. Halogen gets added to the carbon atom with less number of hydrogen. So here n bang hile CH3, CH2, CH2 here carbon hydrogen carbon hydrogen meaning. So according to Markovnikov rule, Br less number of hydrogen. So this Br in a second carbon of add no and hydrogen in a third carbon. First carbon. Normally we have 1 bromopropane minor product, 2 bromopropane major product, but peroxide is a like benzoyl peroxide, anti-Markovnikov addition occurs. So this is called peroxide effect or crash effect. So propene, anti-Markovnikov rule na propene to HBr react na 1 bromopropane ahile major product hige. Preparation of haloarenes. Number 1, direct halogenation. Benzene on treatment with halogen at low temperature in absence of sunlight yields monosubstituted haloarenes. Benzene ahile halogen to treat zangina sunlight omlowina chlorobenzene monosubstituted zangina halogen ahile substitution khatso. However, tuna chlorine bang tampi bang hitale excess aki add bang hitale you can get mixture ortho 1 2 1 3 or 1 4 janakimuthe. Send me a ration when primary aromatic amine suspended in cold mineral acid is treated with sodium nitrate and diazonium salt is formed, which on mixing with freshly prepared diazonium salt with cuprous chloride or cuprous bromide results in the replacement of diazonium groups by chlorine or bromine. Same reaction bangina material aromatic amine happen benzene ring. So this is benzene ring. This is amine group to benzene aromatic amine. na yeah sodium nitrate to halogen acid ki hit khom chang ina benzene diazonium halide ki form benzene diazonium halide pen cuprous chloride cuprous bromide cuprous any halogen group aki react chang ina yeah primary aromatic amine ki thai mo ki bol thai physical properties in a boiling point follows the order RCl alkyl chloride less than alkyl bromide less than alkyl iodide. This is due to increase in size and mass of the halogen atom, which increases the magnitude of van der Waals force of attraction, which is responsible for higher boiling point. A boiling point na hile group ay pa suksukina a boiling point ki sangte de mo sang point sangte do hi ya mitsile magnitude a mass a weight pen ki increase mo a mass pen a size pen ki increase in increase yang ina van der Waals force of attraction ki increase mo van der Waals force of attraction ki increase okay increase yang ina the boiling point pen ho sangze. Number 2, solubility in water. Alkyl halides are insoluble in water because they are not able to form hydrogen bonds with water. However, they are soluble in organic solvents like alcohol, ether, and benzene. Alkyl halides are hele tu to ki bakat tu ya ki dissolve thai lo mo. Himalaya organic solvents like alcohol, ether, they ki dissolve thai. Chemical properties nucleophilic substitution reactions, elimination reactions, reactions with metals, and nucleophilic reaction is in bunks in so nucleophile carbon halogen bond ahile dana ihet sama banga partially charged and polarized no carbon pen partially positive charge halogen partially negative charge so he carbon positive charge niya halogen negative charge niya so this nucleophile incoming nucleophile hele charge groups no having minus negative ions carbon pen easily attack him easily carbon pen babang khate but attack the so because of polarity of manina he nucleophile in carbon pen easily attack the he attack manina two types of substitution reaction ki SN1 and SN2 anwaya discussing SN1 reaction SN1 is a unimolecular reaction unimolecular is a red ahile substrate to ki depend mo it's a two-step mechanism carbocation is formed as an intermediate so racemization of products takes place and usually it takes place in polar solvents like water alcohol and acetic acid in SN1 reaction ahile SN1 reaction is a two-step process step 1 bangom ya matsile hey CH3 example CH3 3Br pen hey C delta plus Br pen delta minus no hey delta plus delta minus pen hey bond pen ki break and sin so when Br pen ki break and sin Br minus on swag mo Br minus on swag takina ya C pen on pen C plus on swag okay so C plus pen next step OH bang nucleophile example na here nucleophile bang gan here OH pen na he carbon here ba take thai mo carbon pen here ba take thai in racemization of products point number 4 racemization of products takes place in C plus pen carbocation here carbocation is a trigonal planar jajangena a shape planar manina OH incoming nucleophile OH in can attack either from the top or from the bottom okay from the attack or they can attack from the front or from the back so nucleophile in a pathway ni ani manina racemization of products takes place racemization is a product ni mo thai mo SN2 reaction rate of the reaction is bimolecular, that is rate equal to the concentration of the substrate and concentration of the nucleophile. It's a one-step process, no intermediates are formed. However, reaction occurs through transition states. Number 4, inversion of configuration of products. So, one-step process here. SN2 reaction. So you have OH minus in directly C plus C pen C carbon of heaven C carbon pen by attack in C carbon pen by attack in he attack jang transition state attack jang chlorine pen apai khan mai mo so apai khan mai na so this one OH in a carbon attack mo carbon to Cl bond pen ki break some amana here dot line ki gal mo so finally Cl minus ang pai khan you have OH H. So inversion of configuration is pen bangchi na here mchile here amasai na H pen here hilam ngena mo so this side hilam ngena means Cl pen hilam mo so after reaction OH na attack nungena OH in here he hilama zwana hi manena here amailama zwan anunglam chi ja amailama anunglam zwan hi manena so this hydrogen thing akhatna ki shift mo ki shift so this hydrogen occupies this side oxygen occupies the other side a change in relative position of atoms ki manena with incoming nucleophile so this is known as inversion of configuration. Stereochemical aspect of nucleophilic substitution reaction. As SN2 reaction proceeds with complete stereochemical inversion, while SN1 reaction proceeds with racemization. In order to understand this concept, we need to learn some basic stereochemical principles and notations such as optical activity, chirality, retention, inversion, racemization, etc. So polarimeter in banga here polarimeter in a sample compound can cut laboratory minus L I can cut here minus D here. So polarimeter in a first how it works is polarimeter in a source of light even more light hila munta ki oscillate light hila munta hija munta bahag mo any wavelength in all direction a wavelength hila all direction apai mo all direction of light wave pen pains and he light wave pen nickel prism ki pass and he polarizer nickel prism polarizer ang ki pass chang ina single wavelength ang pai mo only single wavelength only one wavelength ang pai he pen plane polarized light kichi because it's in only one plane so only one plane here distilled water hisunga sample ki ko jena distilled water bang ombang hitale so this one distilled water hile back swak back demo distilled water in optically inactive ai mana back swak back mal optical active compounds ik ko jangina ni a light pen straight light pen tuna right dextrorotatory bang hitale hi a light pen hi changom hi a light pen sorry lama angom mo right lama angom engine hi abang khat pen hi observer pen hi na hi machine chin hi turning khat engine a right lama hi cha turn ngai mo so a right lama turn changina dextrorotatory kichia minus d kiga khen khat compound khen khat hi left side lama turn ngai mo left side lama turn changina a light ki mu thai mo left side lama light source amte hi light back swakte chini ade hile levorotatory optical isomerism some substances have the ability to rotate a plane of polarized light either to the right or to the left these substances are called optically active and the property is called optical activity so if the substance rotates the light to the right clockwise direction, then I can get mabangamo. It is called dextro-rotatory and is represented by D or plus. If the light is rotated towards the left anti-clockwise, the substance is said to be labio-rotatory and is represented by L or minus sign. Then again mabangamo. Plane of symmetry compound plane of symmetry and yamo. So plane of symmetry is to a molecule tartaric acid bang. Tartaric acid here OH OH C C here C take here CH COH CH COH COH. Now molecule bang here half of divide the length. Half of divide the here 1/2 is equal to the other half more. Plane of symmetry and this is optically inactive. So same with water molecule. Water molecule in a half divide more this side. Divide in a plane I divide more. So water is also optically inactive. Number the center of symmetry molecule in the center of symmetry and optically inactive. A symmetric molecule is referred to as achiral. If an object or molecule lacks a plane of symmetry, it's called dissymmetric or chiral and it's not superimposable on its mirror image. Plane of symmetry compound plane of symmetry plane of symmetry chiral complexes. Chiral carbon stereoisomers relate to each other as non-superimposable mirror images and are called enantiomers. Enantiomers possess identical physical properties but they differ into specific rotation. A 50-50 mixture of dextro and devial rotation enantiomer will have no optical rotation. Such a mixture is called racemic mixture represented by DL or plus minus. So atom bang le hi pen mirror is a chamina it's a mirror bang hile mirror koi bang hile mirror chamina hidan de ong sa no hi mirror ong sa ken chin hi hidan de compound hidan de om de hile enantiomers mo one rotates on khatin kha left khatin kha right are rotate. So this type with dextro or lever rotation pin ma optical rotation nahi daw ma. Causes of low reactivity of haloarenes. In chlorobenzene, the CCl bond is not easily broken because chlorobenzene is a resonance hybrid of various contributing structures. The CCl bond acquires a partial double bond, which in case of methyl chloride is a single bond. Reactivity is chlorobenzene hile compound dangte to bangdia react with kollo ahiam chile chlorobenzene ahile resonance hybrid structures ahia resonance structure ahile chlorine to carbon in a double bond acquires a partial double bond character acquire manina chlorobenzene ahile is very reactivity is very low. Okay. Nucleophilic substitution reactions. Reaction with sodium hydroxide. Chlorobenzene, sodium hydroxide, okay, heat jangina. You have sodium phenate akimoa, sodium phenate pin. Acid to okay reaction in a phenol. Number P, reaction with ammonia. Chlorobenzene ammonia in presence of copper oxide as catalyst reaction in aniline form. Wurtz's phytic reaction in a chlorobenzene is treated with methyl chloride in presence of sodium and alkyl benzene is formed. Chlorobenzene to sodium to alkyl halide. Reaction in benzene or toluene is formed or alkyl benzene is formed. A diphenyl is produced when chlorobenzene is treated with sodium. This is called phytic reaction. Here must depend the words phytic reaction kitchen ani na pen diphenyl akimo na pen. Two molecules of chlorobenzene to two molecules of sodium metal react in a diphenyl molecule. Uses of haloarenes. It is used as an intermediate for preparing dyes. Intermediate is in a dyes in a haloarenes take is no. Number 2, used for manufacture of aniline, DDT, phenol extract. Number 3, it is used as an insecticide. Electrophilic aromatic substitution. Halogens undergo electrophilic reactions such as halogenation, sulfonation, nitration, and Friedel-Crafts reaction. Halogen atom being slightly deactivating is auto-para directing. Therefore, substitution occurs with auto-para versions with respect to the halogen atom. Chlorobenzene. So this is benzene. Happen here, benzene. Okay. Chlorobenzene. Happen here, chlorine, chlorobenzene. No. Halogenation is addition of halogen. So halogen te you have 1,2 dichlorobenzene or 1,4 dichlorobenzene. Nitration HNO3 reaction heats NO2 ki add NO2 at ortho position. Orthochloronitrobenzene here. Second one or para-chloronitrobenzene. Sulfonation is heat sulfuric acid sulfuric acid SO3H add more a product so a product orthochlorobenzene sulfonic acid to para-chlorobenzene sulfonic acid Friedel-Crafts reaction now and orthochlorotoluene to para-chlorotoluene. Uses and effects of polyhalogen compounds. Carbon compounds containing more than one halogen atoms are usually referred to as polyhalogen compounds. Many of these compounds are used for the industry and agriculture. Some of the polyhalogen compounds are discussed below. Polyhalogen is poly is tampimo, halogen is fluorine, chlorine, bromine, iodine. Compound halogen tampi polyhalogen compounds polyhalogen compounds industry agriculture kizangin kizana mo in kizana mo khate ban banai na dichloromethane methylene chloride solvent banai kizanga paint remover propellant aerosols are propellant in second one, it is used as a manufacture of drugs. Number 3, metal finishing solvent. Number 4, it harms central nervous system. Nerve system Number 5, slight exposure to dichloromethane will result in impaired hearing and vision. Dichloromethane iba expose iba ko hile mihingte adinga vision imu te now khozak te now pin bangate mo sete. Higher levels of air in air causes dizziness, nausea, tingling, and numbness in fingers and toes. Dichloromethane hile huilaka concentration asang hile mihingten bangat iluhong amde iluak hong swag iti hong hik suk hik de iti hong in ihete hutte hong pa pong mo. Number 7, direct contact causes burning and mild redness of the skin. Direct contact dichloromethane pen direct ajab khak ahile skin de burn de in sande mo. Direct contact with eyes burns the cornea. Direct contact with cornea pin here covering cornea mo imut na pin happen burned. Number 2, trichloromethane chloroform. Chloroform is prepared from chlorohydrate and methane. Chloroform is chlorohydrate to methane apat kipon na hiya ama hile. Chloroform is colorless is wrong ni lo mo heavy liquid agim na mahile sickly nam hoi kon lo mo agim nam tu lo ama hile solvent in kazanga oils and varnishes chloroform hile freon refrigerant akizang mo anidang nila anesthetic ina kazanga chloroform slowly oxidize in it to produce extremely poisonous gas known as carbon chloride or phosphogen chloroform hile ya huilaka slowly oxidize huilaka oxidize jangina poisonous gas agi form wa hile carbon chloride ahilole phosphogen triiodomethane or iodoform CHI3 iodoform hile iodine to alkali on ethyl alcohol akibola iodoform hile pale yellow solid having melting point of 392 Kelvin nidang ina antiseptic ina kizanga himale anam sian manina to lai to changsana kisang no lawa antiseptic properties is due to liberation of iodine betadine to hong a hisana iodine to a tapia nidang ina tried iodine omzagina antiseptic properties ani kizang mo triiodomethane ahile ethyl alcohol to methanol a distinguish akikhentenadina kizangzena hi carbon tetrachloride chlorination of methane with excess of chlorine at 673 yields carbon tetrachloride carbon tetrachloride carbon tetrachloride CCl4 carbon tetrachloride ahile methane chlorine to in excess akigomchangina at 673 ina carbon tetrachloride kimuthei mo carbon tetrachloride ahile colorless liquid rongomlo having characteristic smell ahile namahile han mama mo ama ahile kwangthei no himane poisonous ahina tuisunga ki dissolve thelo here but in soluble organic solvents man or organic solvents are dissolved no CCl4 ahile fire extinguisher in kizanga under the name pyrene kichimo fire extinguisher kizangte carbon tetrachloride ahile solvent for fans oils and greases in kizanga dry cleaning as on carbon tetride kizangze nahi freon 1,2 dichloro difluoro methane CCl2F2 so freon 1,2 ahile fluorochlorocarbon compound ahia freon ahile extremely stable unreactive non-toxic and non-corrosive and easily liquefiable gases extremely stable is jangina midang to react mo compound dang to ama chok chok example so manufactured by Schwarz reaction freon 1,2 ahile aerosol propellant ahilole refrigeration ahilole air conditioning adinga kibol khazena hiya mane atmosphere tum changina na leitung atmosphere tum changina aman freon radical chain reaction initiate hi radical chain initiate reaction of atmospheric air changina ozone balance pen ozone depletion pen ngam zel no inhamena yada hoilo DDT dichloro diphenyl trichloroethane DDT hele atam to theni wa lungme khom cha DDT gamzel no DDT hele chlorobenzene dichloror in presence of concentrated sulfuric acid bola hiya DDT hele white powder tuya ki dissolve thelo mo himale oil ki dissolve it's an insecticide hiya himale environment highly stable mo environment highly stable din just for ppm mention leisung khonga do chokin chen ikap changa mo ti la khonga mention ki decompose lo he manna environment dia harmful he chapter 10 haloarenes to haloalkanes isim theiting o haitanga hi